Hey guys, today we're doing Stemplots. This is day 4 of our stats unit. Stemplots you've probably heard referred to in Algebra 1 most likely as a stem and leaf plot. Usually the stems are the tens digit and the leaves are the ones digit. Splitting stems, I'll talk about that in a second, as well as pros and cons. I think the easiest way to start explaining what a stem plot is and how it's used is to just dive into this first example. What I have down here is a table of popular Starbucks drinks along with calories and grams of sugar, and it's asking us to create a stem plot to display the data. What I want to do is just the sugar, so we're going to ignore the calories. I put those there just so you could look at for your reference, but I want to just talk about grams of sugar in each drink. What I've done is I've circled the minimum and the maximum here. The minimum happens to be the caramel macchiato. Would not have guessed that, FYI. And the vanilla frap with whole milk and whipped cream happens to be the maximum just for this table. You can go to Starbucks website and get any drink, actually, the nutrition facts. But if I were to create a stem and leaf plot for this, what I'm going to do is I've identified my min and my max. I'm going to draw this big line. And it looks like my numbers go from the 30s to the 60s. So I'm going to do 3, 4, 5, 6. And my minimum value is 32. So that's what I wrote above. I said that the usually the tens digit is the stem, and then you write the leaves over here. Those are the ones digit. So my smallest number here is 32. So I'm going to write a 2 in the 3 row. And so then I'm going to cross this off because I just graphed it, and then I'm going to look for my next smallest number. I don't think there are any other 30s, but my next smallest number happens to be this 40. So then I'm going to put a 0. The next one is 41, which is here. The next one is 42. And the last one in the 40s is 43. And this is how I'm going to create my stem plot. And here's what all the numbers filled in look like. So you can verify just by crossing off these numbers as you go, but that's how to create a stem plot. And so this represents 30, and the 2 here goes with the 3 and represents 32. So we have 4 different drinks in the 40s. 40, 41, 42, and 43. And it is a good idea to put these numbers in order, so it's a little bit annoying. You have to kind of search through your list and keep the numbers in order as you're crossing them off. But what I was writing above, I'm going to go back to this part now. The pros are that you can see every single exact number on this list. It's not like a histogram where you only know there's a certain number of drinks between 40 and 50, for example. You don't know the actual data in a histogram. In this case, you have all of the numbers. You just have to piece them back together. Another thing is we can easily see if there are any gaps. 32, there's only one drink in the 30s, but there aren't any gaps here, meaning that if there was a gap, like if the 4s were left blank, that would mean none of the drinks had between 40 and 50 grams of sugar. Anyways, we could also see modes, mins, and maxes. It looks like the mode here, there are 2 of them. There's 2 drinks that have a 50, and there's 2 drinks that have a 65. Cons, it can be time consuming. This is only 16 different drinks, and it didn't take me very long to construct my stem plot. But if there were like 100 drinks, this would take a while. So that's one of the cons. Another one is it could be really hard to read if there were like 100 different drinks here, or if there was a really small spread. What if all 16 of these drinks were in the 30s range? Then I would just have a giant stem and leaf plot just with the 30s. So that's another thing to keep in mind. If you have a really small spread, then a stem plot's probably not the best way to look at this. Did you know this graph is considered skewed left? So could you turn this on its side, having 3 on the left and 6 on the right, because 3 is smaller than 6, and then your graph would have a tail going to the left. And so that's what we're looking at in terms of, is this skewed in one direction? You can tell that also in a stem plot. I want to talk about this splitting stems. What if I wanted a little bit more information and I had a bunch of numbers here in my 5s and my 6s range, for example? Splitting stems looks like this. I can do 2 different 3s, 2 different 4s. This is allowed. This is one of the rules, 2 different 6s. Okay, and there's only one value for 30, and that was 32. And then I'm going to leave this one blank because there aren't anything between 35 and 39. But my 40s, what I'm going to do is split those. You do 40 through 44, which would be all of those. And then 45 to 49 would be the second one. So I'm going to recopy those. 1, 2, 3. And again, I'm leaving this one blank because there are no drinks between 45 and 49. But the 50s, I can split those also. I'm going up to 4, and then the rest of them are in the different stem. So I'm going to do 0, 0, 2, 4, and the last one is 9. So this is just called splitting stems. In case you have a ton of data, it's a little bit easier to read if you split the stems. And it's also pretty simple to construct, not a big deal, as you can see. So here's what splitting stems would look like. That's the other vocab word that you kind of copied down at the beginning. Anyways, what I have on the next page is a stem plot already given. And what this represents is the percentage of old people in the 50 states and DC. So yes, that does mean that there are 51 states here. You can verify by counting, but it's the 50 states plus DC. Anyways, what is the key for this stem plot? So we haven't talked about a key yet, but what does 6 bar 8 actually mean? Does that mean that one of the states has 68% old people? Well, to answer that question, what do you think 16 bar 8 means? Does that mean 168% of people in a state are elderly? No way. It can't be over 100%, right? So in this case, our key 6 bar 8 actually means 6.8%. And the reason I knew that was because our biggest number, the 16/8, that cannot be 168%. So that's how I knew that. So just keep in mind that if a key isn't given, then that is assumed that this is the 10s and this is the 1s. But most of the time, if it's not, you'll see a key written like this. 6 bar 8 means 6.8%. There does appear to be one state that's significantly different than the rest, so maybe a potential outlier. What about this over here? What's the percentage for this state? What do you think this state is? So this is 6.8%. And what that represents is the 6.8% in a certain state of the people are considered elderly, which is defined here, 65 or older. What state do you think has the least number of elderly people in it? Take a guess. And maybe there's a reason for that, but it happens to be Alaska. And so you can write down a couple notes here, but it's very cold in Alaska, right? Most old people go to Florida when they retire. For example, it's like a stereotypical thought that old people usually retire to Florida. They would probably not go to Alaska. So keep in mind that that is something that you would be asked to maybe consider. It's like, give an idea, give a thought. What do you think? It's not just here's a bunch of numbers, this is the lowest one. Let's actually go a little bit farther and say, what do you think the state is? Why do you think that is? What state has the highest percent and what is it? Again, we're looking right here. That's 16.8%. And on that same key, you are absolutely right. That happens to be Florida, or I'm going to say probably Florida. And the reason for that is because I've heard most people who are elderly, when they retire, they move to Florida, or maybe they get a second home in Florida. Also, FYI, the cost of living in Florida is very small. So a lot of people prefer to pay taxes in Florida on properties that they own versus, I don't know, one of the most expensive places in the entire country, which happens to be the Chicago area. What is the median percentage of elderly in the 50 states? So here is a little bit of a time-consuming question, but you guys know what the word median is. It's middle. And since we have 51 states up here, the 50 states plus DC, there's 51 numbers in here. And so I can figure out exactly what the median number is by just counting. So this is my first, second, third, fourth, fifth, sixth, on and on and on. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This is my middle one, and then there happens to be 25 on the other side. So I could have also counted 25 down. So remember 51, if there are 51 numbers in your data set, that means that there is a middle number. There's a middle number with 25 on each side. So just count to the 25th one, and that percentage happens to be 12.8%. I have no idea what state that corresponds to, but the median happens to be the 26th state. And that's because there's 25 states on each side, meaning like up and down. So So I counted up 25 states. This 26th one happened to be my median. How many states are percentages of elderly higher than 15? Again, one of the purposes of a stem plot is that I can easily answer that question. Higher than 15 would be 15.2, 15.3, and 16.8. So there happen to be 3 states that are higher than 15%. What is the shape of this distribution? Approximately what do you think the mean is without actually calculating it? So again, think about what we know about shape. I can erase some of my scratch work here, just so this is a little bit easier to look at. If we were to turn this thing on its side, and make sure you turn it the correct direction, the 6 is going to be on the left, the 16 is going to be on the right, because the numbers have to go in order on the x-axis. I think this is a little tiny bit, for the most part, symmetric. Maybe there's a little bit of a left skew, maybe slightly, but roughly symmetric. So what I'm going to say is I think the mean is probably pretty close to the median, but this 68 might be decreasing the average a tiny bit. So my guess is, without having to actually calculate this, which I could if I needed to, but for 51 numbers, that would suck a little bit. I think that the mean is probably a little bit smaller. Yes, I'm watching Friends in the background. Than the median. Because maybe the 6.8 decreases the mean a little bit. So that's a pretty not exact answer, but that's okay. That's the point. You could give me an exact answer if I asked for it. You knew exactly what the median is. We answered that in question number 4. I think the mean is probably going to be a little bit less than that. Just a little bit. It is roughly symmetric of a shape, but there is that 6.8, which might drag down the mean just a little bit, making it a little bit less than the 12.8, but not much. That's a perfectly good answer. It shows that you understand what this symmetry tells you about the stem plot, how to find the median, how to find the mean without actually doing it. That is a perfectly acceptable answer. Okay, thank you guys. That is the stem plot lesson. Bring your questions to class. Have a great night, and we'll see you tomorrow.